All right, so we're going to keep talking about chapter 16. What you need to do today for sure, if you don't normally take notes, you probably should take notes. You probably want to write down, we're going to be doing some things with expected value and standard deviation. And there are some rules you have to follow. And I will try to, I'm going to introduce all the rules and I'll go back and try to consolidate that into some easy things to remember. But you probably want to at least write them down so you have somewhere to look at them instead of going and flipping through the pages of the book and trying to find all of them individually. So as a recap, because I know we had Thanksgiving. So as a recap, chapter 16. We were creating probability models, which is a fancy way of saying we're creating a table to keep track of all of the possible outcomes and their associated probabilities, correct? That's what a model was, right? And within that model, we found an expected value and a standard deviation because we can't find a measure of center without a measure of spread. So your expected value was your mean or your average, and then you found a standard deviation of your model, okay? So again, keep in mind expected value is the same thing as the average or the mean. So if they ask you to find the average of something with a model, it means to find the expected value. So make sure you equate those as the same thing in your brain. Expected value is the same thing as the average. Those are equal, okay? So on all of those problems, we made a model, we found an expected value, we found a standard deviation, yada, yada. That's pretty much what we've done so far. Would you agree?
Yeah.
So today we're going to start talking about what happens when we start altering data and within our altering outcomes within our model. Like what happens if I want to add a constant to all the outcomes? Or what happens when I want to multiply all the outcomes by a constant? Or what happens when I want to put two random variables together? Like remember a random variable was just like defining the scenario pretty much? What if I have carnival game A and I have carnival game B and I want to know my expected winnings for both combined? All right, or the standard deviation of the expected winnings, or the standard deviation of the winnings combined. All right, so we're going to talk about what you do to combine random variables too. All right, so here's what I need you to do. I need you to think back, way back to Unit 1. All right, because we've kind of done a little bit of this before with means and standard deviations. We've talked about mean and standard deviation, so that's not a new concept. All right, so in your brain, or I guess I can draw one out here, but probably won't be very good. Let's say we have some histogram of something. I don't know, histogram of some stuff. Well, they hate you back. Okay, so you have some histogram, whatever. This one's unimodal and symmetric, so you'd probably say the mean is somewhere in the middle. Would you agree?
Yeah.
Okay. So with the measure of center, we also said there's a measure of spread, and so whatever the standard deviation was is just telling you how spread apart everything is from the mean, right? Okay, so let's picture this. We did this, but we're just going to picture it. Let's say I decide that I want to add 10 units to every single data value in the histogram. All right, I'm adding 10 units to every single one. If I had 10 units to every single data value in the histogram, what happens to the histogram? It shifts, right? So this histogram is going to shift up 10 units. Is it going to look any different? No. So it looks the exact same. I wonder if I can get this to work. Oh, maybe. Aha. Thanks. Thank you. Thank you. All right. So we shifted up 10 units. So this is the new mean would have been the mean what? Plus 10. Right? Right? Okay. Whatever the standard deviation was of the histogram, that's this measure of spread, right? Did the spread change at all?
No.
No, it did not. So the standard deviation was not plus 10. It was just whatever the standard deviation was. Does everyone recall that happening back in the day? Then we also talked about multiplying. But if we multiplied everything.
Yeah.
Right? Okay. Well, that's what we're going to start today. All right? Same idea, different application. Okay? So, because we're dealing with expected values and standard deviations of some random variable. So, let's say we're going to add or subtract some constant to every single outcome. So you're playing one of those carnival games that we've done in all the homework.
Right.
And instead of winning $10, $20, or $30, I say bump that up $10. So you're winning 20 $40 or $50. Or I think I just did that wrong. 20, 30, and 40, whatever. You're adding $10 to all the outcomes, okay? So if I shift that, I could redo the model, all right? And I redo the model, I could recalculate the expected value and recalculate the standard deviation. But sometimes you don't have the model. Sometimes they just give you the expected value and the standard deviation of the scenario, right? If you're just given the expected value and the standard deviation of the scenario, then I can't recalculate it. I have to know what to do. So you're given the expected value and the standard deviation of the carnival game, and I say you should add $10 to all the possible outcomes, then what's going to happen to the expected value? If I said to add $10 to all the possible outcomes, what happens to the expected value?
It shifts up $10.
You would add the $10. The standard deviation would remain the same because, again, the spread doesn't change. Just like we just did, we're just talking about it in the sense of expected values. Okay? So here's your first rule. If you add or subtract a constant to your random variable, then you just add or subtract that constant to your expected value. Just like we did in Unit 1. That's not really anything new. Again, just different application. It's not calculus. This is an actual value. It will be a number. I promise. No, this is an actual value that will have a number equated to it. This is not a capital C. This is a lowercase c that is just a little constant that will be an actual value.
It does. Oh, no. I didn't know that.
Okay. Now, we've been talking about variances instead of standard deviation. All right. So the variance is just the standard deviation squared. So it says here that if we add a constant to the random variable, that we don't add it to the variance. So I can make up a rule if I wanted to. This says the standard deviation, if you add a constant, that you don't add it to the standard deviation either. Or we could say that. Again, that's what we learned in Unit 1. Like, that's not new. It's just, again, new wording here, expected value and variance. But the idea is the same. So if you're adding or subtracting a constant, you do so to the mean, but you don't to the standard deviation or the variance, measures of spread. Everyone clear on that? Okay. The second thing we talked about in Unit 1 was when we multiplied everything. Now, this one gets confusing for a second, so bear with me. The first rule here, if we're going to multiply, we're rescaling everything. We multiply by a constant. We multiply a random variable by a constant, then we should just multiply the expected value. No big deal, right? If we had the standard deviation and we multiplied by the constant, then we would just multiply by the standard deviation. We did that in Unit 1, correct? Okay, but again, all the rules in this chapter are based on variances. So how do I get from the standard deviation to the variance? Square it. So to get to the variance, I would have to do this part squared, right? Right? Because you're squaring it to get to the variance. So because of that, you would have to square the constant before you multiplied it by the variance. That is the math behind this rule. Okay? Because this variance is the square of the standard deviation, then instead of just multiplying, you have to square that constant that's associated. Just the constant. Because, well, you're squaring the standard deviation that is the variance. Okay? So far, there's a pattern. With the expected value, you just do what it says. Right? With the variance, you don't ever do what it says. Right? You got to think about it. All right. These sort of make sense, though, from things we've talked about before. You should have some frame of reference about where this is all coming from.
Yeah.
Now, the other rules we're going to talk about today. What happens when you have two random variables that you want to combine? All right, that's what we're going to talk about. You can combine them. It's all good. There's just some things to think about. So first thing, if you want to add or subtract, so I'm putting the plus or minus there, plus or minus. Add or subtract two random variables. Okay? Maybe X is some dice game that you're playing, and Y is some card game that you're playing, and there's winnings associated with both, and you want to know your expected winnings together. All right? Well, if you're adding and subtracting the random variables, you just add or subtract the two expected values. No big deal. It's turning out that the means are not an issue. Okay? So if you have the average winnings for one, you have the average winnings for the other, you just combine the averages. No big deal. Questions about that? Now, before I go to the next thing, we're going to think through this. Because obviously the rule for variances is not on here, or standard deviation. First thing, there is no rule about combining standard deviations, so you can't do that. All right, there's nothing proven about that. Okay? So because of that, we always have to combine variances. So even if they give you the standard deviation of both, you have to square them both to have the variances of both so you can combine the variances. All right? We will always combine variances and not standard deviations. Okay, everyone with me on that? Second thing, right? The variance is a measure of spread. It kind of tells you how variable a scenario is, right? So, just think through this with me. Because if not, it won't make any sense to you. So think through, focus. Carnival game 1 has a variance of whatever, right? That just means that there's not the same thing happens every time, right? There's a measure of spread involved, right? There's some variation in the amount you win or whatever, okay? Carnival game 2, same scenario, all right? You have some game and there's some variability involved, right? There's variability in both of these games. So if I wanted to combine the variances, I wanted to add the variances of both the games, that's totally fine. You can do that. Not an issue. Add them all you want. All right? But if it says you're trying to subtract two random variables, if you subtract the variances, that means you're saying that there's going to be less variation than you started with each one individually. That doesn't happen in real life. If there's variability in one thing, and there's variability in the other thing, if you try to combine them, there's going to be more variability. Does that make sense? You're never going to be able to take away variability. Okay? So here where it says you can add or subtract the expected values, if the scenario calls for you subtracting the variances, you're still going to add the variances. All right? So that's what this next rule says before we get there. Okay? So you can add and subtract two expected values, but you can only add variances. Again, even if the scenario is calling for you to subtract in the expected value realm, you will only be adding variances because, again, you will always have more variability, not less. Does that make a little bit of sense? Okay. So here's what you should have gotten out of these rules. These are all the rules. So here's what you should have gotten out of all the rules. With the expected values, you just do whatever it asks you to do, right? They say to add, you add. They say to multiply, you multiply. They say to combine some things, you combine them. It's not an issue. Expected value, you just do whatever they say. But with variances, like literally, you hardly do exactly what they say. Okay, so here is my summation of the variance rules. They want you to add or subtract a constant. You don't do that for the variance. They want you to multiply by a constant. You got to square the constant first before you multiply it by the variance. And if you're going to combine random variables, you always have to add them. All right? So that's my summary of how to deal with variances. I can. Again, with the expected values, there shouldn't be any confusion. You should do what it tells you to do. Right. But with the variances, things are tricky. So Then a second, we'll do some examples, and I'll give you the assignment. On the assignment, the first two questions have nothing really to do with what we did today, just a review from before Thanksgiving, so you get that into your mind. All right. Then I'm going to do some examples that have no context first. All right, just using the rules, but there is zero context involved. Like it's not about anything, it's just a table of numbers. All right. So 2 of your homework problems will just be that. Just have numbers, just you practicing the rules. And then the last part of the homework will be practicing the rules, but they'll be in context. All right, and I'll do an example of that too. All right, so is everyone good for me to move on?
Yep.
Okay. So it says given independent random variables. This is an important concept that I kind of skipped over a second ago. If you're going to start combining variables, all right, you're combining two scenarios. If you combine them, they have to be independent, right? Independent just means they don't rely on each other. They don't affect each other. It wouldn't make sense to just add the two averages if one thing affected the other one. That wouldn't make any sense. So you have to have independent random variables to do any of this. That makes sense. I just didn't mention it. Okay? And it says with means and standard deviations as shown, find the mean and standard deviation of, and it gives us 5 different things we're doing. All right? So the mean and standard deviation of x and of y. I'm going to go ahead and add in the variance as a column because we're going to need that to answer some of these questions. So if the standard deviation is 12 for x, what's the variance? 144. 12 squared. If we have the standard deviation of y is 16, then the variance is 16 squared, which if I remember correctly from this morning is 256. But someone probably double check that. Okay. Now, we don't need that for every question, but we might need it for some of the questions, right? So when we start combining variables, you can't combine standard deviations, you have to combine variances. So we're going to need that in part of the problem, so may as well just have it already. Okay? So I'm going to start with A. A just says, again, we're finding the mean and standard deviation. So expected value and standard deviation of 0.8 times y. So if I'm finding the expected value of 0.8y, we just do whatever it says for expected value. So what is the mean of y? $300. So it should be 0.8 times 300. So $240. Questions about how I found that expected value? You just do what it says. For the standard deviation, if you're just multiplying, you can do that. So we just do 0.8 times the standard deviation of y. That's allowed. So we get 12.8. If they had given you the variance, and they didn't give you the standard deviation at all, then you would have had to do 0.8 squared times the variance. But they gave us a standard deviation, so we're good. We'll have to do some of that stuff later. Okay, but for this example, we're good. Questions on A? We're just multiplying, so we can do those things. All right, let's look at B. It says to find the mean and standard deviation of 2x minus 100. So what am I going to do to find the expected value of 2x minus 100? You're going to do exactly what it says. So 2 times 120 minus 100. So 2 times 120 is 240, and 240 minus 100 is 140. Questions about how I found the expected value? Now, for the standard deviation, We multiply constants, but do we add or subtract them? No. So in this case, we're just going to do 2 times 12, but we're not going to subtract the 100 because we don't subtract constants or add constants to standard deviation. So 2 times 12 is just, yeah, I don't know. I was going to write 48, but I don't know why. So 24. I know. All right. So questions about B. Just be careful. Remember, you don't add or subtract constants to the standard deviation. Okay, we good with B. Now, C, D, and E are all combining random variables. So on C, D, and E, I can't use the standard deviations because we're combining two variables, and that's when you have to use the variances. There is no rule about combining standard deviations. There are rules for combining variances. Okay? So keep that in mind. So for C, first we'll find the expected value of x plus 2y. So how do I find the expected value of x plus 2y? Yeah. So 120 plus 2 times 300. So that's 720. Does that make sense? Now, it's asking in the question for you to find standard deviation. So we're going to have to find the combined variance, and then at the end, take the square root to actually answer the question. All right? But again, we can't combine standard deviation. So we'll have to do the variance of x plus 2y. So what's the variance of x? But then it says 2 times y. So we'll have to do 2 squared, we have to square that constant, times the variation of y, which was 256. So that's when that rule comes into play. When you're using variances, you're going to have to multiply by the square of that constant. So I'm going to need my calculator. 4 times 256 plus 144. Thank you. I appreciate that.
No, I wasn't answering the question.
Now, we have the combined variance, but it says to find the standard deviation in the question. So if I have the variance, how do I find the standard deviation? Just take the square root. So square root of 1,168. It's 30 something. I don't know what it is. So 34.2. Questions about C? All right, let's keep practicing. We got 2 more. On D, it says 3x minus y. So for the expected value, again, we just do what it says to do. So we have 3 times 120, which is 360, minus 300, which is 60, as Jacob keeps telling me because he's impatient. Questions about how I got 60? Again, to combine variables, we have to do variances. And we always said there's always going to be more variations. So even though there's a subtraction symbol, when we go back to do this, we're actually going to add. All right? So I have 3 times the variance of x. So you have 3 squared times 144. So I know it says minus, but we're going to add 256. Right? There's always more variability, not less. So we don't subtract. So 9 times 144. And then we need to find the standard deviation. So we take the square root. What did you say it was, Jacob? You guys are driving me nuts. Okay. Questions about D? All right, one more. Now, on E it says y1 plus y2. That just means you have maybe you have one carnival game and you play it one day, and then you go back and play it the next day. So it's the same thing. You're just doing it in 2 different instances. Okay? So still the same rules apply, but it's just telling you what y1, y2 is. So the expected value of y1 plus y2 is going to be what? Y1 plus y2 is 600.
Oh my god.
It's just y twice.
Oh my gosh. What the heck?
300 plus.
Okay, I didn't see the X. It's the Y.
Right, okay, excellent. And then for the variances, we add variances. There's no constant being multiplied here. So we can just add 256 plus 256, which Jacob is being the calculator today, so that is...
No, I don't. Hold on.
W-
Wait.
Thank you.
Y plus Y is different from 2 times Y in this situation.
Right. Y plus y would be different than 2 times y because we wouldn't be able to just multiply by 2. We'd have to do 2 squared. So be careful about that. And then, so then what is the standard deviation going to be?
Square root of 512.
I know, but Jacob's calculating. All right. Questions about those? So the part of your homework is just doing that. We okay with that?
Yeah.
All right. Let me do one in context for you. So you can, because I need to make sure you think correctly on how to do some of these questions. A delivery company's trucks occasionally get parking tickets. And based on past experience, the company plans that the trucks will average 1.3 tickets a month with a standard deviation of 0.7 tickets.
Why don't they park in the
Good question. So they're telling us in the question the expected value is 1.3 tickets and the standard deviation is 0.7 tickets. All right? And so if we needed it, which we're probably going to need it, what would be the variance? Okay, 0.49. Okay, so we just square the standard deviation. All right. You square the standard deviation.
Oh my
Yeah.
gosh, she was silent.
I know.
You're like,
So they gave us, in this case, was just what I was talking about earlier. We don't actually have the model, all right? So if they tell us to add 18 to everything or add 12 or whatever, we can't recalculate it. So we have to base it on these rules, and we know these 3 things. All right, everyone with me? In part A, it says, if they have 18 trucks, what are the mean and standard deviation of the total number of parking tickets the company will have to pay this month? We have to be really careful how we think of things because, as we just talked about 5 seconds ago, Clay mentioned it, I'll mention it again. 18 times x is not the same thing when you do variances and stuff as x1 plus x2 all the way up to x plus 8, x18. All right, does that make sense? The rules are different for variances. All right, so you would give different answers. You need to make sure you're thinking about it which way it's supposed to be thought about. So if you have 18 trucks, X is the average number of trucks, average number of tickets per month for one truck. All right? So am I taking one truck and multiplying by like 18, or do I have 18 individual entities? We have individual trucks, right? We have independent trucks from each other, 18 independent trucks. So because we have 18 independent trucks, we need to think about it this way, not that way. Okay? That ensures that when we do the variance and the standard deviation, we get the right answer. Okay? So we have 18 individual trucks sitting in the parking lot. So if I'm going to find the expected value, then I'm going to find the expected value for the 18 added together. Now, because algebra, we know that there's a simple way to do that, right? I don't have to actually go through and do 1.3 plus 1.3 plus 1.3 18 times. That's the same thing as 18 times 1.3. I get that. That's why I'm making clear distinction about which way we're thinking about it, though, because of how it's going to affect the variance part in a second. All right? So we have 18 times 1.3. Thank you. Jacob's just being so helpful today. 23.4. So in a month, they're going to average 23.4 tickets. Okay? Yeah? Now, for the variance, again, this is what I have to think about this way. If we're doing the variance of 18 individual trucks, because we can't combine standard deviations, we can only combine variances, right? I can just go through and add the variances. That's fine. So it'd be 0.49 18 times. Again, because of algebra, we can do 18 times 0.49, right? But that's what we don't do 18 squared. All right, we're not doing 18 squared because we're not thinking about it as 18 times a variable. We're thinking about there's 18 individual ones. So we have 0.49 being added to itself 18 times. So that's where we're getting that. So Jacob, what's 18 times 0.49? Okay. And then it asks for the standard deviation of the total number of parking tickets. When you take the square root real fast. So what's the square root of 8.82? Perfect. So they expect to have 23.4 parking tickets during the month from the 18 trucks with a standard deviation of 2.97 tickets. Does everyone understand the distinction of thinking about it as 18 times the variable and the variable 18 times?
Yes.
Okay, make sure you think about that in the problem so you don't get confused. Because if not, you'll get confused. All right, so B says, what assumption did you make in answering? In order to be able to use these rules, we have to assume that every truck is independent of each other. All right? So if they're not independent, if you think the trucks are related, the parking tickets are related somehow, then you wouldn't be able to use these rules. Okay, then here's your assignment.